Numbers 13 through 15 on the Unit 5 study guide. Says a car stops at a stoplight and then begins to drive, starts at a stoplight and begins to drive. At various times, the car's velocity is given here. We are first asked to set up an integral that could be evaluated to find the distance that the car drives over the 21 minutes. And then we are asked to use a Wright-Riemann sum to approximate the distance, including units. The very first problem we have here, this is the velocity is measured in miles per hour, and the time given here is in minutes. So we need our units to match up. These are minutes, and this is measured in hours. There's a couple different ways you could do it. Probably the most common way, since this is miles per hour, is to change this to hours. So if that's 3 minutes, I need to take those 3 minutes and divide by 60. Gives me, this is 0.15 hours. 6 divided by, oh, that was 3 divided by 20, sorry. 6 divided by 60 here, we've got 0.1 hours. This should be 0.05. 9 divided by 60, and so on. 0.15 hours. 0.25 hours, 0.35 hours. So divide all your times by 60, that's 0 hours. Now our units match up, which is what we want. We are trying to first set up an integral that's going to find a distance. So our integral would be from 0 to 0.35 hours of v of t dt. There's the integral. It asks us to use a Wright-Riemann sum to approximate that. So this base is 0.05, and our height, we are doing a Wright-Riemann sum, so we use the right height. From 0.05 to 0.1 is 0.05 units, right height. Base is 0.05, height is 37. Base from 0.15 to 0.25 is 0.10 times a height of 45. 0.25 to 0.35 is 0.10 times height. We are using 31. Multiply there and add them up, and we get our answer. Once you multiply it out, we should get 11.85. Units for distance in the problem is measured in miles. Number 14. Asks us to set up an integral that could be evaluated to find the average velocity over the 21 minutes. So average velocity, and we're given velocity, so that's an average value problem. So we want to do 1 over b minus a, 0.35 minus 0, times the integral from 0 to 0.35 of v of t dt. It asks us to use a trapezoidal sum to approximate the velocity. So trapezoidal sum, area of a trapezoid, 1/2, sum of the bases, 0 plus 22, times the height. The height is 0.05, this distance right here. 1/2, sum of our bases is 48, times the height, 0.05. Sum of the bases on the next interval is 63. Height is again 0.05. Sum of these bases is 82. Height this time is 0.1. And our last interval, the sum of the bases is 76, and the height is 0.1. And then again, it's a matter of typing that into our calculator. Once you've evaluated the Wright-Riemann sum, don't forget to divide by 0.35. Final answer rounded to the nearest thousandth is 32.071 units for velocity or miles per hour. And then number 15. asks us to find the average acceleration over the interval. Average acceleration given velocity. Acceleration is the rate of change of velocity. This is an average rate of change problem. We are looking over the entire 21 minutes, so starting at 0 and ending at a time of 0.35. We just find the slope between those 2 points. 31 minus 0 over 0.35 minus 0. Use the calculator. Gives us 88.571. Units would be miles per hour squared.